History isn't just made, it's manufactured. And right now, sitting on a launch mount in South Texas is a 400-foot moving skyscraper that is about to break physics. This is Starship version 3. The machine designed to end the era of exploration and begin the era of industrialization. We aren't just talking about another rocket launch. Flight 12, scheduled for mid-March 2026, represents a pivot point for human civilization. It's the formal debut of the Mars invasion architecture. Thousands of tons of cargo, a vanguard of humanoid robots, and a plan to build the first self-sustaining city on another planet. The NASA era as we knew it. It's transitioning. The engine of space development has shifted from government science projects to a private sector industrial model. Today, we're breaking down the specs of the most powerful machine ever built, the secret robotic labor force heading to the Red Planet, and why the moon is no longer the finish line. It's just the first pit stop. To understand why V3 is physics breaker, you have to look at the scale. This stack stands at 124.4 meters. That's over 408 feet tall. It has grown from the original prototypes by stretching its propellant tanks in both the Super Heavy booster and the Starship upper stage. But it's not just bigger, it's smarter. SpaceX has been aggressively cutting dry mass, the weight of the ship itself. They dropped it from 100 tons in V1 down to a target of less than 80 tons for V3. They did this by integrating the vented interstage directly into the booster's structure, removing the need for a separate 1.8-meter attachment used for hot staging. Even the internal domes are different. They moved from conical to elliptical shapes to handle the extreme cryogenic and aerodynamic loads. And to survive the fire of re-entry, they've added a crunch wrap, a felt-based material stuffed between the hexagonal ceramic tiles to stop plasma from seeping into the ship's skeleton. The heart of this beast is the Raptor 5.3 engine. If the rocket is the body, this is the muscle, and it's terrifyingly efficient. SpaceX completely redesigned the plumbing. All those external lines that used to vibrate and fail, gone. They are now internalized, making the engine lighter, more robust, and, get this, 4 times cheaper to manufacture than the Raptor. Chamber pressure pushed to over 350 bars. The Super Heavy booster uses 33 of these engines to produce 80.8 meganewtons of thrust. The comparison, that is over 18 million pounds of force. To put that in perspective, it is more than twice the power of the Saturn V that took us to the moon. On the upper stage, you have 6 engines, 3 for landing on Earth or Mars, and 3 RVACs, vacuum-optimized engines with massive nozzles designed to provide the delta V needed for interplanetary travel. Here is the twist you didn't see coming. The first Martians won't be humans, they'll be Tesla Optimus robots. Elon Musk has confirmed plans to send these humanoid robots to Mars as early as late 2026. Why? Because space is a logistics nightmare. Humans need food, air, and pressurized habitats just to survive the trip. A robot only needs power. The Optimus Martian labor force will deploy solar farms and small nuclear reactors. They will mine subsurface water ice and operate plants to convert Martian CO2 into methane and oxygen propellant for the trip home. The ultimate von Neumann goal is for these robots, running advanced AI models, to eventually use local materials to replicate themselves. An exponential labor force that builds the city before the first human even steps off the ramp. Building a city requires millions of tons of equipment. Starship V3 is the conveyor belt. It can carry 100 to 150 metric tons to low Earth orbit in a fully reusable configuration. But getting to Mars isn't a straight shot. It requires orbital refilling. Before a V3 Starship leaves for Mars, it has to be refilled in Earth orbit by 8 12-tanker Starships. Once the tanks are topped off, it can haul its full 100-ton payload all the way to the Martian surface. The landing is the ultimate adrenaline rush. No parachutes. The Martian atmosphere is too thin. Starship hits the atmosphere at 7.5 kilometers per second, uses its belly flop maneuver to slow down, and then performs a landing flip to touch down vertically on its engines. While Mars is the long-term goal, the money is being made right here in orbit. SpaceX's valuation is surging toward $800 billion because space is becoming critical infrastructure. We are seeing the rise of orbital data centers, server farms in space that avoid the cooling bottlenecks of Earth. We're seeing planetary-scale sensor networks using Starlink satellites to track every piece of orbital debris with total fidelity. And then there's the geopolitical race. The overhaul of NASA's Artemis program was a wake-up call. With China aiming for a 2030 lunar landing, the US is pivoting to a go big and go now strategy. NASA is now leaning on private industry because the Space Launch System costs $2.5 billion per launch and only flies once a year. Meanwhile, the Star Factory in Texas is aiming to build one Starship every week. Starship V3 is more than a rocket. It is the physical embodiment of a new era. It's a machine that treats space not as a scientific curiosity, but as an industrial domain. The specifications are locked in. 124.4 meters tall, 80.8 meganewtons of thrust, and a payload capacity that makes everything else in history look like a toy. As Flight 12 counts down for its mid-March debut, the logistics for the Mars invasion are being verified on test stands right now. And as we reach further into the cosmos, we're finding things that shouldn't exist, like a star that predates the birth of the universe. Witness the star that exists outside of time, right now.